So trigonometry students, this is intended to be just a few more examples of the application problems involved in Chapter 7. There's going to be a variety of problems. Some will deal with navigation, some won't. Some will use law of sines, some will use law of cosines. And we really needed to get through the whole chapter in order to do all of these together. So these are just extra examples. This first one doesn't involve navigation. It talks about a parallelogram. So I'm going to go ahead and draw a parallelogram. And a parallelogram looks something like this. We know the opposite sides are parallel. And then we're talking about the diagonals. It says the diagonals are 18 and 15. So if I was to draw in my diagonals here, the shorter one obviously is the 15 and the longer one is the 18. They're bisected, so that would mean that each of these longer pieces is 9 and each of these smaller pieces would be 7.5. And they tell us they intersect to form an angle of 52 degrees. As you can see, they're going to intersect at a central angle in there, and one of them is going to be obtuse and the other one's going to be acute. So I'm going to put the acute one right here at 52. If I take 180 and I subtract 52, I find out that this one up here is 128 degrees. And then they ask us to find the length of the longer side. Now that's an important distinction there because the longer side is going to be the one that's across from that obtuse angle. So I'm actually going to be using that top triangle right here. And since we have two sides and an included angle, two sides and an included angle means we're going to use law of cosines. So it's law of cosines. When I set it up, we'll just call this one x. I'll have x squared equals, and then 7.5 squared plus 9 squared minus 2 times 7.5 times 9, and then the cosine of 128 degrees. Now, they didn't specify what to round to, so I'm going to round on all of these problems to the nearest tenth. All problems to the nearest tenth, unless it specifies. Okay, so down here, when I enter that in my calculator, I need to take the square root, 7.5 squared plus 9 squared minus 2 times 7.5 times 9 times the cosine of 128, 14.8. Not a particularly complicated problem. We did have to remember from geometry the diagonals of a parallelogram bisect each other, and then we had to know that the longest side was going to be across from that obtuse angle in the center. Number 2. Now, number 2 is a bit of a navigation problem, and it says that we have two ships that leave the same harbor entrance, and they leave at the same time, and the first ship is traveling at 18 miles per hour, and the second is traveling at 22 miles per hour. Okay? The angle between their courses is 123 degrees. Okay, so one of the ships is traveling at 18 miles per hour. We don't know the direction, but it's going 18 miles per hour for 2 hours. So that would be 36. And then the other ship is traveling at 22 miles per hour, and we know the angle between their courses is 123 degrees. And that one's traveling at 22 miles per hour for 2 hours, so 44. And then they ask us to figure out how far apart they are. So we're looking for the distance between these two. Okay, looks like again we have two sides and an included angle. So once again we have law of cosines. And if I set it up, I will have x squared equals 36 squared plus 44 squared minus 2 times 36 times 44 times the cosine of 123 degrees. And we said at the beginning that I was going to have you round to the nearest tenth. So I'll take the square root, 36 squared plus 44 squared minus 2 times 36 times 44 times cosine 123, 70.4 miles apart. So a little bit of a navigation problem, but very similar to the one we did in problem 1 with the parallelogram. Number two is another navigation problem. Now, again, it says 2 ships leave the same harbor. One ship is traveling 14 miles per hour, and the course is south 13 degrees west. So here is my harbor right there. And then south would be straight down. That's south. So 13 degrees to the west would put us over here. And we're traveling along that line. We're going 14 miles per hour for 3 hours. 3 times 14, so that's 42 miles on that one. And keep in mind, this angle up here is 13 degrees. The other ship is traveling in the direction north 75 degrees east, so I need a north line. This was my south line, so I'll need a north line. There's my north line. And then 72 degrees to the east, or 75 degrees to the east. So 75 degrees will be this way. And that one's traveling at 12 miles per hour. So it'll be a little bit shorter. So it's 12 times 3. So that's 36. And then we're looking for how far apart they are. So once again, we're looking for the connection between those endpoints. Right there. Well, I think this is going to be the law of cosines again, but first we're going to have to find an angle in the triangle. And the angle that I think we're going to be able to find is, I think if I take 180 degrees and I subtract 75 degrees, I get 105 degrees. So this is 105. So that means that whole angle, this whole angle up here, that angle will be 105 plus 13, so that's 118 degrees. And again, it's law of cosines. So I'll have x squared equals 36 squared plus 42 squared minus 2 times 36 times 42 times the cosine of 118 degrees. So square root 36 squared plus 42 squared minus 2 times 36 times 42 times cosine 118, 66.9 miles apart. Again, a law of cosines, but this one involved a little bit more navigation. We had a little more complicated diagram. Number 4 is what we generally think of as a navigation problem. There's an airspeed and a wind speed, and then they ask us for our final direction, our true course, and our ground speed. So since it's a navigation problem, we are going to start out with a north line. And then the plane is traveling at 272. Well, 270 would be straight to the left. So 272 is going to be in this direction, right there. And it's going 244 miles per hour. And this whole angle here was 272.2 degrees. Okay, now the wind. Now the wind is going to be acting on the end of this, so I'm going to draw a new north line right here. And the wind is in the direction 262.6. So the wind is going to be not quite straight to the left, a little bit down. This angle right here is 262.6 degrees, and the magnitude of that is 45.7. And again, the resultant, the true path that we travel on, will be this line right there. So that's our ground speed. And yet again, we're going to have to find an angle in the triangle. And the angle that we're going to try to find is going to be this angle up here. Okay. Now, first of all, we have supplementary angles. So if I take if I take 360 and I subtract 272.2, I get 87.8. And that's going to be this angle right here. And then, if I take 180 minus 87.8, I get 92.2. That's this angle out here. And then finally, if I take 262.6 and I subtract 92.2, I get 170. Okay, 170 is going to be this angle right here. And now we can use our law of cosines. So the x squared will equal the 45.7 squared plus the 244 squared minus 2 times 45.7 times 244 times the cosine of 170 degrees. So my ground speed comes out to be square root 45.7 squared plus 244 squared minus 2 times 45.7 times 244 times the cosine of 170. 289.1. miles per hour. Okay, now to find our true course, first find the angle theta in the triangle. And theta is going to be the angle over here. We're going to find it using the law of cosines. So the cosine of theta is going to be equal to, now the 45.7 is across from it, so that means I'm going to have the 244 squared plus the 289.1 squared minus the 45.7 squared divided by 2 times 244 times 289.1. My theta comes out to be inverse cosine, and then 244 squared plus 289.1 squared minus 45.7 squared, that whole quantity divided by the quantity 2 times 244 times 289.1, 1.6 degrees. And we've actually been pushed a little less than our 272 that we wanted to. So our true course, we're going to have to take 272.2 and subtract 1.6. So our true course is 270.6. A little bit more complicated on that one, so look it over, stop it, pause it, whatever you have to do. So good luck on that one. The last one. The last one's another navigation problem, and in this navigation problem, the plane was traveling 140 miles per hour and traveling in the direction 130 degrees. The ground speed of the plane was 135, and its true course was 137. So let me see if I can set that up for you. So first of all, here's our north line. And 130 degrees, so 90 would be straight to the right, 180 is straight down, so 130 would be somewhere over here. So that's 130 degrees. And our speed is 140 miles per hour. Okay? But we actually get blown a little bit down to the south. So 137 degrees would put us a little further down to the south. Now I exaggerated that a little bit. So this red angle here is 137 degrees. And we actually get slowed down a little bit. So I'm going to make it a little bit shorter. So let me make that just a little bit shorter than the green one. It's only 135. And then they ask us to find the speed and direction of the air currents. Now the air currents actually would have acted on the end of this airspeed vector. So what we're looking for here is we're really looking for this one right there. We're looking for that, and we're looking for this. Okay, so how can we figure that out? Well, one of the things that we probably noticed right away is this angle is 7 degrees. So we can use the law of cosines. The x squared will equal the 140 squared plus the 135 squared minus 2 times 140 times 135 times the cosine of 7 degrees. So our wind speed is 17.5 miles per hour. That's the wind speed. Now, as far as the direction goes, well, to get the direction, let's see. I think we can find the angle theta in the triangle right here. And then I think we'll be able to use that to figure out our direction of our wind. Again, this is the direction of the wind. So let's find theta. And we'll use the law of cosines. So the cosine of theta will be equal to, the one across from it's the 135, so I have the 140 squared plus the 17.5 squared minus the 135 squared divided by 2 times the 140 times the 17.5. So theta comes out to be inverse cosine 140 squared plus 17.5 squared minus 135 squared, that whole quantity divided by 2 times 140 times 17.5. 69.9 degrees. Okay, so if this is 69.9 degrees, and then I know that I have supplementary angles, so this one is 50 degrees. So to get my wind speed, or my wind direction, rather, I can take 360 minus 69.9 minus 50, and for my wind direction, I get 240.1 degrees. And that's the wind direction.